Welcome to UCLA Grand Rounds. This is the first session of the 2021 season. And for those who haven't been here before, please remember that you can ask questions through the Q&A part of the webinar screen at any time, and we will go through those questions at the end of the talk. It's my great pleasure to introduce Charles Raison, Chuck Raison, who's here from the University of Wisconsin. Dr. Raison started his career as an undergraduate at Stanford. He then trained in medicine at WashU and came to UCLA for his internship and residency, where I first met him. And I can say truthfully that some of my fondest memories of residency are talking to Dr. Raison about science, literature, psychiatry, art. Dr. Raison's fund of knowledge is truly remarkable, and he's been able to apply that to his current studies. After leaving the residency here, he was briefly assistant professor at UCLA, then moved to Emory, where he did groundbreaking seminal work in psychoneuroimmunology that many of you are going to be familiar with. He was then recruited to Arizona and finally to the University of Wisconsin, where he's now a distinguished endowed chair in both behavioral ecology, in human ecology and psychiatry. And over the past 25 years, he's managed to apply his amazing fund of knowledge in spirituality, compassion, mindfulness, religion, history to psychiatry and generate a truly unique and I think brilliant way of thinking about psychiatry. So please welcome my friend and colleague, Charles Raison.
Oh. Well, thank you, David. Back at you about the good times in residency. I've been thinking about a lot of them because I knew I was going to be talking today, and I'm not going to, tempted as I am to tell a few stories, I'm going to keep my mouth closed and let's just jump right in. So I am a UCLA alum, as David said, and was there from 91 to 99, actually, and then went off to Emory. Well, the talk I'd like to give you today is really at the cutting edge of how I'm personally thinking about things these days. This is not a talk that's going to be laden down with a whole bunch of data. I hope to do something a little bit more outside the box for you, consistent with the title, which are words we don't often see together, but I think they'll make sense when we dive in. So here's the learning objectives. I'm not going to belabor those. Let's start a little further back than we usually do for these sorts of grand round conversations. And let me talk a little bit about the assumptions upon which I think this talk is based. And, this may sound woo-woo, but I actually don't think so. I think these are the core questions for all the subject matter we're going to cover. And I want to start with a very simple question, which is whether civilization will survive as we understand it. Well, maybe not. It's been kind of a wild week. If civilization doesn't survive, if we enter another dark ages, if Mad Max and Road Warrior turns out to be the future 100 years from now, this talk is moot. Everything I'm going to talk about will be pretty much irrelevant. So for this talk to be of any value, civilization has to survive. Now, if civilization survives, there's one certain thing that is going to happen. There's no doubt about it. It's been happening at warp speed through this whole COVID thing, if you follow computational stuff, which is computational power is going to expand exponentially. I mean, there have been so many advances in quantum computing in this last year that there's just no doubt about it. So if we survive, this is going to happen. Now, if this happens, the key question is really whether or not artificial intelligence will become called general artificial intelligence, where it will develop what we understand to be consciousness, a take on the world wherein it privileges its own ends and purposes in ways that we recognize as being related to conscious beings. If this happens, I don't need to go tell you to go see the Matrix. This is Terminator, Matrix. This is all science fiction. Rightly understands that, if an unbelievably brilliant entity was also out for itself in ways that were equally complex, we would be to it the way perhaps a lab rat is to us. Whether it would keep us around or not, I think is a really complicated question. I wouldn't hold my breath. So if AI develops consciousness, I'm sorry I've wasted your time again with this talk. But on the other hand, it is also, I think, at least as likely that consciousness will turn out to be a rather difficult thing to build. It clearly doesn't track with intelligence. I mean, machines are far more intelligent than we are now, but they don't show any sign of consciousness. So many people actually think that some sort of human-computer hybrid is going to end up, at least for the short term, being the optimal evolutionary entity, because you get the consciousness sort of free from the human piece of it, and then you get the computational power of the computer, and that may not be able to be beat. It may not be worth trying to get AI to be fully conscious, because it won't need to be. So that it's that outcome that this entire talk is based on, that line of reasoning. But I need to take a little bit of a digression and talk for a minute about just a very, very simple evolutionary idea, because it's going to come up throughout the talk. So I want to talk a little bit about proximate versus ultimate goals. And I'll give you a little thought experiment here. You see the picture. So take a look at this picture. It evokes in most of us a certain set of feelings. Now, different feelings. Some people might think it's salacious. Some people might think it's a turn on, but we all recognize it as being a certain type of thing. I want you to look at this, and I want you to compare that to this. And if you weren't a human being, you didn't know any better, you would say, well, those two things have absolutely nothing in common. The valence, the look, the whole deal is completely different. And yet, you know, and I know that the picture on the left is what leads to the picture on the right. Now, sex is the classic example of an evolutionarily generated proximal goal. A proximal goal is something that an organism will pursue for its own sake without question. If you make a list of the things in your life that you just take to be good, sex, friends, power, status, money, these are all things that tap into things that the human brain unquestionably follows and will follow slavishly to the point of death, right? We mostly kill ourselves over these proximal goals. So what evolution discovered a long time ago is what advertising has discovered, you know, in the last, say, 100, 200 years, that, when you see the Marlboro cowboy, good looking, rugged guy with a cigarette, why that picture? Why don't you just have a simple statement? Please smoke cigarettes. They'll get you addicted and cause you to die young. Because that's the ultimate goal, but nobody's going to smoke with that message. So you come up with a proximal goal that links it to this other outcome. So, it turns out that having children across evolutionary history is a very dangerous undertaking. Women died at high rates throughout, till really 20th century. It's not an easy thing. So evolution has hit upon this proximal goal, and it's hit upon it repeatedly, that if you're going to share half your genes, if you're going to put, if you can't get, you're only going to get half your genes in that next generation, you need something that is so incontrovertibly pursued for its own sake that it'll do the job for you, right? And so, if you look at the anthropologic literature, there were many hunter-gatherer folks that did not understand that the sex act was necessarily what led to having children. Certainly not that one sex act would produce one child. So, sex existed long before people could fully grasp that connection. It evolved because it's a proximal goal. It is pursued for its own sake. It's pursued for its own sake because by being pursued for its own sake, it, without forcing the person to be fully aware of it, leads to survival, reproduction of offspring, which is, of course, the goal of evolutionary processes. So here we go. Here's a little cartoon. There's a human, and he is trying to get to those proximal goals, and I've just tossed up some of them. So, all human societies have needed food. They've needed to sexually reproduce. Humans don't have much fur. They need some kind of shelter. And we are just the quintessential non-social insect species, social animal. And so status everywhere, in all places and all times, has been very much related to increased sexual success, but also survival. There's a whole talk we could give about that, but for today, I just encourage you to take my word for it. So here comes a human. The ultimate goal is enhanced overall evolutionary fitness. Now, most of us are not wandering around worried about our enhanced overall evolutionary fitness, but we sure as heck are thinking about those proximal goals. So we want to get to those goals. How does it happen? Well, across millions of years, there was a species typical pathway. I mean, humans adapted to all sorts of different ways of life, but there were some constants across pretty much all societies that were the sort of hunter-gatherer setups that humans evolved in. Effort. Took a good deal of effort to get those proximal goals. Took a good deal of risk. I just reading this thing about like the Hadza, how when they're doing a persistent hunt and they're chasing something, if they see a honey, a beehive in a tree, they'll immediately scale the tree and go for the beehive. Well, sometimes they get stung to death. Sometimes they fall out of the tree. It takes a lot of risk, takes a lot of time. And time is a very, very high cost because none of us have ever had enough of it. So, across almost all of evolution, this is what it was. To accomplish these proximal goals, significant species, typical types of activities were required. But the thing that's fascinating about human beings more than any other animal is while all this was going on and we were evolving this species typical pathway, it was having this interesting effect of starting off of a sort of explosive of sort of technology revolution where people begin to develop these intersubjective realities, as the historian Harari calls them. They are hacks. Human consciousness began to come up with structures that could be shared between people that did not exist in the real world, but that allowed a massive shortcutting of the work and effort that was typical across human evolution. Consider money. Money is the most fascinating of all intersubjective realities. Why do you spend most of your life, pursuing it? Why do we let some people live in giant castles and other people sleep on the streets? Because they have money or don't have money. What is money? Money is numbers nowadays in some computer, but we live or die for it. We fight for it. These intersubjective realities, they're not real the way a stone or a tree is real, but they are real in terms of having very powerful actions in the world. And what's fascinating about all these intersubjective realities is, to a large measure, they seem to evolve to short circuit the more dangerous, time-consuming species typical pathway of old. So we can make a list of some of these intersubjective realities in addition to money. Physical ease, being sedentary. I mean, that goes way back. Primates like being sedentary. No animal wants to waste energy. Energy is always in high supply. So we are able to be unbelievably physically sedentary. People were always hungry. We have copious amounts of high-calorie food. We have these novel ways of fighting pathogens like antibiotics. If you're all turned on and you're wanting to procreate, we have outlets for it like pornography, where you can get all sorts of stuff that the typical hunter-gatherer couldn't get. And if you can have 1,000 friends on Facebook, I mean, beautiful short-circuiting of face-to-face reality, right? So you would think, because all of these intersubjective realities make it so much easier for us to achieve proximal goals. And remember, we're not consciously thinking about the enhanced overall evolutionary fitness. Evolution is playing this trick on us. It's driving us crazy to achieve those proximal goals. You would think that all of these sorts of things would be profound producers of happiness, because again, energy is always at a premium, and these are remarkable sort of hacks, shortcuts. So I find it unbelievably fascinating that if you make a list of all these sort of intersubjective realities that short circuit the way we used to do things, they don't make us happy. Actually, they tend to make us depressed. And this is worth thinking about for a long time, because it's not so clear why this should be. Now, what I'd like to do in this talk is give you one way of thinking about why this should be. This is all just theoretical. I offer all this to you just to sort of stimulate our thinking about this. This is true, though. We know that these human modern eases are generally depressogenic. Well, I want to suggest to you that the reason that they are depressogenic is because, despite having evolved a mandate to short-circuit species typical pathways whenever possible, selection had previously favored those who received a hedonic reward from these very pathways. So, there aren't very many hunter-gatherers around anymore, because once agriculture got invented, that was a short circuit, that was an intersubjective reality. And, the old ways couldn't compete. We see this over and over again in technological evolution. But on the other hand, I'm very interested in human running abilities. And, there's some pretty strong evidence that many groups likely in Paleolithic times, before they had large axes and weapons, were able to chase down larger game by running them to death, just because we can thermoregulate so well and run such long distances. So think about running. Um, if you have to run to eat and you happen to have a genetic makeup that gets more of a sort of a dopamine push when you run the animal down, or when you're given higher status when you bring the animal back to camp, you're more likely to go out and do it. So what I'm suggesting happened over these, literally a couple million years of evolutionary time, is that the risk, the effort, the time, all these factors got baked in to an association for why the proximal goals make us feel good. And because of that, we need some degree of species typical pathway exposure. And here I'm talking about adaptive stress, right? So many of the things that we now have to do voluntarily, we used to have to do to survive. And they were physical stressors and psychological stressors. We need some degree of species typical pathway exposure for success at proximal evolved mechanisms to confer sustained well-being. People that were grown up poor and had to work for their money tend to feel better about their money than people that inherited it because they were born into a rich family. It's really no more complex than that. Well, okay, so if you think about these intersubjective realities, which have also been called extended phenotypes, they become part of us and who we are. They have been around for a long time, from stone tools and fires. And of course, now they're becoming deeply interconnected. We're all over with the computer stuff. They really exist to make life easier, to short circuit the old ways we had to do things. And of course, the most recent old way we've had to do things is talking to our phone, talking to our computer, type. There's a gap between us and that computer capacity. People are working very hard to close that gap. Neuralink, of course, from your former state citizen, Elon Musk, and eventually, something like this, some sort of half human, half machine. Well, the thing, though, is that these cyborgian processes, if we can call them that, risk weakening the human component by removing these pathway-dependent stimuli, these adaptive stressors that humans need to experience well-being. And because well-being is largely pathway-dependent and only partly goal-dependent, judicious re-exposure to these stimuli will be essential. Because take a look at our man there over on the right. Well, the computer can be kicking butt and taking names and doing this and doing that. But if the human element is coming apart, if our iPhones let us have thousands of friends and do tons of stuff, but if we're getting more and more depressed and non-functional and feeling like killing ourselves, this arrangement will not work. The AI and the human elements they'll fall apart. The human elements will wither away and die, or they'll develop conscious states that are not going to be things we want to have enhanced by artificial intelligence and robotics. So, basically what I'm saying here is that if we want to go forward into a future where the human consciousness plays a significant role, we have to think about what does it take to keep that consciousness functioning properly. Not to go back in the past and hunt buffalo, but what do we have to do so that we can get the sense of reward for what we're doing in our life that tends to enhance our well-being? And I'm not just talking about the brain. So, one of the things that are being developed are these exoskeletons, right? So you got one of these, you can be like Superman, right? And you'll be stronger, faster than any normal human can be. And of course, there'll be competition, and pretty soon, everybody will have some degree of this, so that we can run faster, lift harder. But it's interesting. Those suits will do that partly by taking pressure off of bones. And just recently in the last year, it's been shown that there's a chemical called osteocalcin, which is released from bones when pressure is put on them. And that is an absolutely essential chemical for mammals to mount stress responses. Osteocalcin turns off parasympathetic signaling. You can adrenalectomize a rodent and you can still get a stress response because of the bones. Makes sense evolutionarily, bones evolved to help animals run or swim. So of course they should be involved in fight and flight responses, and it looks like they are. You don't have a functioning stress response, you're not going to have a good mental health, right? So back to the suits here, you know, the combined creature is just like, you know, a physical god. But unless we think about how to keep that human part of it also tuned up, strengthened, subjected to enough adaptive stress to maintain their equilibrium, it's not going to work. The human part will wither away and become non-functional. So I want to suggest to you that one of the things facing us as a challenge in the modern world is that judicious re-exposure to these sort of adaptive stress stimuli will be essential. We're going to have to find some way to get these back in our lives so that life feels more real again. I mean, that's another way to think about it. Feels more actual, feels more satisfying, feels more human. So, you know, the question, of course, is how. And here, I want to make a distinction between active and passive renunciation. So the problem in the modern world, well, there's many problems in the modern world, but the particular problem here is that many of the things that were adaptive stressors that humans evolved to get the signal of success, hedonic pleasure, feeling a purpose from, many of those, in fact, all of them were things that they didn't have to choose to do. They just had to do it. Yet I'm reading this new book by Daniel Lieberman called Exercised. And it's interesting, you know, hunter-gatherer folks, they didn't run around all the time. If they could, they would sit and take it easy. And there's this great thing where they're talking about, they see him running in the morning for no good reason, and they're dumbfounded. Why would anybody waste energy running if you didn't have to, right? So these things used to have, where they were things everybody had to do. You had to eat certain type of food. That food over evolutionary time became what humans do best with. You had to have a fair amount of exercise because you'd starve to death and die otherwise. You know, you had to go without food sometimes because going without foods was just how it was, right? But in our time, if you want to fast, if you want to exercise, any number of these things, they're active. They require renunciation. And renunciation is a bitch. It's a hard thing to do, as any of us can tell when you try to lose weight, for instance. So let me give you an example of this idea, though. So, you know, the idea here is that, you know, if the world was simple, you'd think that just eating a bunch of high calorie food would really make you undepressed. But we know that's not true. In fact, you know, if you do it long enough, it's a big depressogenic risk factor. You wouldn't think that going without food would make you feel better, but it does. And there are now, since I made this slide, there's even now some studies in older folks where they've done intermittent fasting. Whatever else we might say about fasting, the data suggests that it is both a mood elevator and an antidepressant strategy is really growing. It'd be one of the things I'd most love to study because I think that it holds some real promise. And of course, fasting is one of the oldest religious you know, sort of things in the world. You know, long ago, people had some memory that there was something about going without food that sharpens the mind and opens the heart. And it's a hard thing to do. So it got ensconced within religious traditions. I mean, it's just remarkable how universal it is. And you have to ask yourself, you know, like, why were the Native American folks in California? I mean, like I come from near Fresno. I mean, they were always fasting for anything having to do with religion. But so were the folks over on the other side of the world, you know. So why? Well, it's because it produces these positive mood states. Same thing with exercise. Amazing. You know, exercise clearly has mood elevating and has antidepressant effects. Running in particular has been picked up by spiritual traditions all around the world, where they push running to an extreme, where it's not really physically healthy, but it's a methodology for inducing these sort of hyper expansive mental states. But the problem with fasting, the problem with exercise for people that are depressed is that behavioral activation itself is very hard when you're depressed. So I am interested in another adaptive stressor that we don't think as much about as we might, which is thermoneutrality. Mammals in particular, warm-blooded animals, crave thermoneutrality because if you are in a cold place or a hot place, you are going to burn way more energy, and nobody wants to burn energy. That's one of the cardinal laws of life. Don't waste energy. So this is why we have air conditioners and heaters, and you know, we've got it enough now where we just don't don't realize how powerful this is and how novel it is. Nobody had this. Well, recently there have been the development of these wearable air conditioners and heaters, and they're really fascinating. You can see it. It goes there, and it basically tricks your brain. If it's cold there, it sends a signal up to your brain that you're in a cool room, and vice versa with hot. Now, from an environmental point of view, these things are great, right? Imagine you could be in a room, everybody could have one of these little battery powered things, and you could keep the room at 85 and they'd think that they were sitting in 72. So sort of from that perspective, these things are great. But the strong prediction of what I'm talking about is that if they become widespread, they should be depressogenic. And over time, they should lower people's moods and make them less happy, because humans clearly evolved in conditions where their bodies had to react to very different types of temperatures. And like running, like fasting, thermoregulation has been one of the most strongly usurped adaptive stressors for healing and spiritual matters, and as we'll show you actually now, depression. So, if thermoneutrality was the way to enter into heightened, altered, elevated mind states, sweat lodges would have been put out of business a long time ago. But it is remarkable how really almost every culture in the world has something like a sweat lodge or a sauna or a bath. Again, California was sweat lodge central, especially up in the Central Valley. The men would do it every day pretty much. And I don't know if you've ever been in a sweat lodge. I was in a Sioux sweat lodge one time, and it's a miserable experience. You're suffocating. It's hotter than hell. You can't breathe. It's dark. It was rough. I crawled out on my hands and knees, and it really gives you a charge. It gives you a charge. You feel better. And so sweat lodges have been picked up in the modern world. These guys need more than a sweat lodge to get into optimal shape, but there they are. And it explains what I think is one of the most confusing, nonsensical practices that I know of in the modern world, which is hot yoga, right? Especially like in LA, right? Y'all could go do your yoga on the lawn. You got the beautiful grass because you got the water from the Colorado River, and you got the blue sky, and why are you paying good money to go into stiflingly hot yoga studios and do your yoga there in discomfort, in smelly discomfort? And, I realized a few years ago why this is so. This is so because heat is an antidepressant. And my colleagues at Harvard are just about to publish a study where they've actually studied Bikram yoga. And yes, it definitely works as an antidepressant. So I've had a long-term interest in heat. It sort of fell into my lap about 2010, 2011. I was teaching in Austria, and I and a couple of the graduate students decided we were going to do a study on whole body hyperthermia in depressed people. One of the young guys who worked in this mental hospital was an alternative mental hospital. They did Reiki and acupuncture, but they had an old hyperthermia machine down in the basement, which he rebuilt. And we rounded up 16 people that were depressed enough to come into a hospital. 3 of them were taking SSRIs. The others were off everything. And we cooked them up. We put them in this hypothermia machine, which had been used for cancer. And we heated them up to a core body temperature of 38.5, which is 101.3, which is the edge. That's the top edge of what's called mild intensity hyperthermia. And we measured their depression score the day before. And we measured their depression score 5 days later. No comparative condition, just a small study. Everybody got to treatment. But the result was pretty striking. Here with the SSD, it dropped their scores by about half. We had a follow-up at 90 days out. And of course, people have gone on to other treatments and stuff, but they were still, in fact, their scores were lower. During this period, though, nobody took an antidepressant. Nobody did anything. Interestingly, though, the 3 people that were on an antidepressant had no response whatsoever. And it may be that SSRIs, there's a serotonin story with hyperthermia that the SSRIs may obviate. Well, based on that, we got some money, and I got one of the German guys you see here, and we moved to Arizona, and we got a newer, fancier hyperthermia machine, which is this. And we decided we were going to do a larger It still turned out not to be very large, but a larger randomized blinded trial. We had to figure out the comparator condition, right? So, you come into a hypothermia machine, they make a big deal about it. You think you're going to get treated. All the placebo elements of these interventions are really high. So we came up with something kind of clever. You can see if you look at the slide, those big barrels, those are the infrared lights that just pour down that heat on the person's chest. We went and bought 4 desk lamps at Target, painted them orange, built a baffle around that top part so people couldn't see it, put in a fake fan, and decided we were going to give the people that got the sham condition a little bit of heat. There's these heating coils at the bottom of the box. We actually ended up giving too much heat. Some of the people actually pretty much got a full treatment, but it just made them kind of warm and cozy, most of them. And because we did that, we asked everybody when they got out of the box, did you get the real thing or the sham? 71% of the people that got the sham treated condition thought they had the actual hypothermia. And 95% of the people that got the full on thing, not every depressed person who got really cooked thought they got the actual thing. There's sort of masochism and depression. They thought, oh, there must be something worse than that, sweat's pouring off their body. But anyway, it was an interesting study that way because of a nicely matched comparator condition. And when we looked over 6 weeks, the red is the active hypothermia, blue is the placebo. You see very large effect sizes, but that's because the blue didn't work very well. But that's good because it says that just putting you in a box and making you think that you're getting hypothermia doesn't do the trick. There's something about the heat. You can see that, really it's over 2 weeks where the slopes of the lines are different. But we saw about the same thing, not quite 50% overall. We had a couple of people in this study that actually went into full remission, like for months. And there were some people that didn't respond. But in general, the vast bulk of people felt considerably better. Well, David mentioned that I had done a lot of work in psychoneuroimmunology. So, we had to see what this did to the immune system. And we thought that it would be an anti-inflammatory strategy. We thought that if we just measure cytokines in the blood a week later, the TNF and IL-1 and IL-6 would be down. We did not see that. If you just look at these, 9 graphs, and you can immediately see that one is different. The only thing that we saw in this study was that IL-6 has a very, very powerful immediate rise. We measured it just before they got in the box, just after. We don't know when it went back to normal because it's a week later, but this was a huge effect. It went up, I don't know, I think like 40 times, something like that, which is quite interesting because most of us think about IL-6 as a bad guy, right? I mean, that is the cytokine that's most often elevated in the blood of people with major depression. So we kind of wondered what was going on here. But there's a precedent for this. So, when you get really sick with an immune disorder, like sepsis, for instance, overflooding of gram-negative bacteria, and you get all this endotoxin, the first thing that happens is that these 2 key inflammatory cytokines, IL-1, mostly IL-1 beta, and TNF, tumor necrosis factor, they shoot up. They activate IL-6. And then IL-6 definitely does some inflammatory things, but it also activates some anti-inflammatory things, including IL-1 receptor antagonist, and of most interest is interleukin-10, IL-10. But look at exercise. So if you go out and run 2 or 3 miles, you will get a signature that's very similar to what we got in our box. Exercise, aerobic exercise, and the stronger it is, the more you see this, jacks up IL-6 big time, but it doesn't jack up TNF or IL-1 beta. So the idea here, and we published a paper on this a year ago, IL-6, a good kid hanging out with a bad crowd or something like that, where we make the argument that, IL-6 is a bad guy so often because it's traveling in the company of TNF and IL-1 beta. But there are these things you can do that just activate IL-6 and sort of thereby unleash its compensatory anti-inflammatory potential. So this does not prove it, but if we just look here at a simple correlation between how much your IL-6 went up from right before to right after the treatment and how undepressed you were a week later, it's a pretty nice correlation. When you do modeling and all that, it just barely, it comes in at like 0.07 or something like that, p-value. But clearly, the IL-6 going up is not making people feel more depressed. So this is really quite striking. So what am I saying here? I'm saying, we're going to all go around with little packs on our back so we can be thermoneutral and environmentally conscious. And it's going to feel great because you're not going to be hot and you're not going to be cold. And if you just do nothing but that, you're going to get depressed. That's the argument here. You're going to get depressed. You're going to feel out of sorts. Conversely, you go into a sweat lodge and you just subject yourself to this massive heat, and you come out and you feel enlivened, inspired, activated, right? So here is a classic adaptive stressor. This is a thermal adaptive stressor. That's why people like hot yoga. And these are things, simple things that you can do. One of the great attractive things about this hypothermia is, yeah, the person's got to get out of bed, but all they have to do is lay on the bed in the machine. They don't have to go run. It's a way, in fact, people are now writing about hypothermia as a potential sort of a replacement for exercise in type 2 diabetes around these same problems of people not wanting to be activated. So there you go. It's really quite interesting. Now, there's a bit of another story with this hypothermia. And so this is a study over on the left that was done in the 90s at UCLA, here at the Semel Institute, where Marty Zuba managed to get people to wear rectal probes for 24 hours. And he rounded up a bunch of depressed people, and he rounded up some normal controls, some of whom were residents that we were with. And he looked at their body temperature across 24 hours. And what he found was, and this has been shown in many studies, the depressed people are hot. Depressed people do not sweat compared to non-depressed people. They've got as a group, they tend to have a deficiency of thermoregulatory cooling. So what's cool about the study, though, was that then Marty went and he gave them all ECT, all the depressed people, measured their core body temperature again. Boom. This is literally what happened. It went down to the normal controls. Over on the right, there's a whole pathway, these various spinothalamic and spinoparabrachial pathways, whereby heat on the skin signals these key serotonergic brain areas. Well, so I'm telling you that depressed people are too hot. Now, if nature was simple, you'd think that if somebody was depressed and cold, you should heat them up. And if somebody was depressed and hot, you should cool them down, right? But the logic of hormesis, or the logic of these adaptive stressors, often says the opposite. It says, if you see something that is out of balance, push it a little bit harder in the same direction. And sometimes that stress is adaptive and it will cause a resetting or a sensitization. So indeed, when we measured core body temperature in the smaller study in Germany or Switzerland, this is a pretty nice correlation. The hotter people were, the day before they got in the hypothermia machine, the more undepressed they got a week later. So if you're hot, you did better. Why? Because that extra heat is doing something really interesting. So over on the left is now from pre-treatment to 5 days post-treatment with one hypothermia session, its core body temperature over 24 hours. And so the hypothermia treatment was hot as all hell, but its long-term effect was hypothermia. It cooled people off. So we think that this is a classic example of an adaptive stressor sort of sensitizing, exercising a system and restoring it to more of an appropriate homeostatic balance. Not that many people that we had both of these on, but this is a pretty whopping good correlation. The more people's body temperature fell, the more undepressed they got. And of course, I think that's because the pathways that are regulating thermoregulatory cooling are very much involved with mood and related types of symptoms. I just throw this up. This was just from a couple of days ago. We're working on a grant. I just threw this up to tell you that it's driving me crazy. And, the things we're talking about are far more complex than the overview I'm giving you today. All right. So we've talked about physical stressors, using bodily based stressors, almost like deep brain stimulators to change brain function. Is there a role for adaptive psychological stress in the treatment of depression? And of course, if I'm asking that it's a straw man question. I want to suggest to you there is. And I want to suggest to you, in fact, that the earliest substances that were psychoactive and employed for changing people's minds, particularly the psychedelics, are very often a type of psychological stressor. Psilocybin comes from magic mushrooms. It's been around for, we don't know how long, but certainly from before the time of Cortez, rediscovered in the late 1950s by Gordon Wasson. If you're in mental health, if you don't know about psychedelics at this point, you're living in a cave in the woods. I've never seen anything take off like this. This is generally how it's been done. This is Roland Griffith's lab at Hopkins. Mary Casamano is sort of one of the world's great guides. People come in. This was a study of depressed, anxious cancer patients. Half of them got a placebo, half of them got a high dose of psilocybin. They take the psilocybin, they put on the eye shades, they listen to music. Psychedelics make music very, very emotionally powerful. And the guides are with you for 6 or 7 hours, and you have this intense experience. And it really looks like there's something about that experience that does the deed. So what happens in these psychedelic experiences? Because the data to date suggest that depending on the condition, a single treatment or 2 treatments will undepress and bust anxiety in people for anywhere from 6 months to 4 or 5 years. This is why people are so interested. It's a single treatment, and yet it seems to have these profound long-term effects. Well, what is it? We know, or we think we know at least, it's something about the experience that happens while the people are having a psychedelic trip. Very often that experience has been called peak or unitary or mystical. People have a sense that they're connected to something beyond themselves, that their life has a purpose that transcends their own troubles, that although they have suffered, they're contributing to something that matters immensely. They're part of a larger whole. This is often a very blissful experience. You don't need psychedelics. It can be induced by all sorts of things, whirling dervishes, meditation, chanting, and the experience is very similar. Plenty of studies show that the more people have that kind of experience when they've taken psilocybin, the more something they are a month or 2 later. So this one is anxiety, but I could show you a similar chart for tobacco smoking, for depression. People that have this unitary experience, they see life differently after that, and it changes how they feel, at least for a fairly protracted period. But anybody that's worked in this field, especially in people with depression, knows that yes, sometimes that happens, but there's a lot of other stuff that happens. And one of the most common things that happens is that people take the psychedelic, they lay down on the couch, and they begin to have extremely painful emotional experiences. The drug seems to haul up out of their unconscious, all the things that they've been experientially avoiding. And so people have these intense experiences, weeping, crying, and many people would never do it again. It's not easy. And so there's data for this. This is a large survey study from Roland Griffith's group, just showing that in 2,000 people, the harder the psychedelic experience was, the better people said they did afterwards, the more well-being they had. Now, the longer it went on, the worse well-being they had. And there's almost certainly an explanation from that, and it probably has to do with this. So here's the world's leader. This guy is like the king of psychedelics, Robin Card-Harris, good guy over at Imperial College London. He comes out of the psychoanalytic tradition. He's recognized, and very correctly, that mystical experiences are not the whole gig, that for a lot of people, especially people with psychological distress, it seems to be something more like what he calls emotional breakthrough. So he developed a questionnaire that you can see some of the questions. I faced emotionally difficult feelings that I usually push aside. I experienced a resolution of a personal conflict. Well, so there's a first factor, which has to do with facing your feelings and overcoming them, coming to peace with them. There's a second factor, which is things like I was resisting and avoiding, and I felt stuck, so you just feel horrible and you can't get out of it. That can actually make people feel worse. But I'm not doing justice to the really quite amazing degree of data that's amassing, suggesting that when you can metabolize psychologically difficult material under a psychedelic, people often get this profound release. So let me make a couple of analogies and then we'll quit. This is the year to do this. I want to think about vaccines versus antibiotics. So let's stop thinking about psychiatry for a second and think about immunology and the paradox of anti-vaxxers, since vaccines are so much more remarkably safe than antibiotics. So, vaccines do not go kill viruses. they strengthen already existent co-evolved immunologic mechanisms in the host. They introduce you to the virus without the virus killing you, but they don't drive an arms race. Whereas antibiotics are all imported from totally different animal kingdoms, and they are novel in the environment in which we take them, and they did not co-evolve with us. So because vaccines use co-evolved mechanisms, they don't induce evolutionary arms races that promote resistance. Sometimes there are certainly viruses that will mutate and you have to keep kind of tweaking your vaccine, but it's nothing like antibiotics where, one of the classic arms races in all evolutionary history, of course, is between bacteria and antibiotics. I don't need to tell you that. Vaccines have a low rate of off-target adverse effects. Yes, every once in a while somebody will get myasthenia gravis or whatever, but they really are quite safe because, again, all they're doing is administering a safe form in one way or other of the virus so that your immune system learns and can take care of itself. As opposed to antibiotics, they have a huge rate of off-target adverse effects. There's now all sorts of just sort of cohort-based data showing that antibiotic use in childhood is a risk factor for allergies and asthma, but also ADHD, conduct disorder, anxiety. Antibiotic use in adulthood is associated with subsequent development of depression. There's a whole literature on this. Well, the effects of vaccines far outlast their presence in the body because they've initiated a self-sustained and self-contained physiologic process within the body. You don't need to keep seeing the vaccine because the immune system takes it for there. It's got memory cells. You just tap it and it takes off and has a self-contained life on its own. Antibiotics, of course, the effects are limited to their presence in the body. That's why if you stop an antibiotic course early, you can get in worse trouble. And they may weaken beneficial self-sustaining and self-contained physiologic processes. They are bad for the microbiome, and we're increasingly realizing that what's bad for the microbiome is bad for us. Vaccines have tremendous disease prevention potential. Antibiotics, very limited or no disease potential. Vaccines are absolutely essential, but guess what? So are antibiotics. But they're very different. Vaccines should have the widest spread use as possible. Antibiotics, even though we're using them that way. So it's ironic, we're curtailing vaccines and giving antibiotics to the cows. Antibiotics should have the targeted, most limited use because they cause secondary reactions that make them ineffective after a while. And so my final point is that, in psychiatry, we really need to add treatments to our repertoire that behave more like vaccines, to our current treatments that behave more like antibiotics. And if we were going to take a coffee break, come back for another hour, and we could look at all the data showing that, God bless antidepressants, but they do look like antibiotics. They set up resistance in people. They can sponsor tachyphylaxis. Treatments that operate via adaptive stressors share a number of features in common with vaccines. They operate by strengthening co-evolved physiological or behavioral pathways. They may not induce tachyphylaxis, and their side effects are time limited because the exposure is time limited. Their effects outlast the presence in the body. Even in our hypothermia study, we got 6 weeks. And therefore, they may also hold potential as preventive strategies. But, for a long time to come, standard treatments are going to remain an essential component of the armamentarium. So I'm not calling for the downfall of traditional psychiatry, but just an encouragement that, we've been antibiotic doctors all these years. We should really begin to think a little bit more like people that work on vaccines. So with that, let me stop. I think we have like 9 minutes. I will close my slides off. David, did we have questions?
Yes, we have, starting with 2 questions. One question is regarding heat treatment. And the question is, does hypothermia have similar antidepressant effects as hyperthermia?
Probably. Nobody, it's really interesting. Nobody's put it, nobody yet has put it to the test. Alyssa Eppel of UCSF did a study with Wim Hof, and she won't tell me what the results are, but I think they'll come out this spring and we'll see. Cold, when it comes to the skin, cold and heat do very similar things in terms of the receptors they activate. And something that people often ask me that we don't have the answer to is, what about the fins? Should we be, hot, cold, hot, cold, hot, cold? Maybe. We don't know. I mean, there's a lot of work that could be done in this area to try to understand ways to optimize it.
Thank you. Another question is going deeper into the effects of hyperthermia. And does it have effects on only severe depression? Does it also work for mild depression? And does it work for unipolar and bipolar, or just one? How broadly is it applicable?
Yeah. Well, again, we're kind of in the beginning of all this. UCSF is actually starting up a hypothermia program, and Harvard is. The data we have suggests, it helps people that are also just mildly depressed. I mean, I bet folks that are listening to me, there's going to be a subgroup of you out there that are doing hot yoga, or you've always wondered why taking a hot bath makes you feel better. So yeah, now how good it is for really severe depression, that's what we don't know. We had some people in our study that were pretty depressed, but I mean, like people that are desperately depressed, we haven't done that yet. Bipolar disorder, don't know. My fear is that it would induce a manic episode, right? Remember back in the old days, what they did with bipolar agitation was they wrapped them up in cold, wet sheet packs. So to the question about cold, that was clearly one place where cold was very effective, and by all accounts, at least as effective as neuroleptics with like manic agitation. Just wrap them up like a baby, kind of in a cold, wet sheet, and it just calms them down.
Thank you. Another question here, and I'm going to paraphrase it, or at least maybe go to the end. Do you think that with all of the current technology, there's going to be an evolutionary process selecting for individuals where solely online social relationships induce an emotionally healthy state?
That's a great question. That's a really great question. With world enough in time, yeah, that'd be the prediction, right? Evolution goes real slow when everything's hunky-dory, right? When things are in balance, when the forest is mature and in a climax state and the climate's not changing, it'd be really, really hard to start a new company. You know what I mean? The space is taken. In times of great upheaval, that's when evolution can click along at a shocking pace, right? So one of the problems we have is that our cyborgian sort of things we do have become disconnected from reproduction. So the people that can have the most satisfying relationships online are not necessarily going to leave the most progeny. But if it's just so damn miserable for the rest of us that we leave less progeny or kill ourselves or something like that, yeah, I mean, organisms do tend to adapt into the environment that they exist in. The problem with technology, though, is that what we call online today will be gone way too fast for evolution, for human evolution to be worked upon. I mean, as soon as we're wandering around in virtual worlds that begin to look very much like this one, it's not going to be the same thing. We're in a transition zone now. So but if we knew that we were going to have cell phones and video games and it was going to be like this for the next million years, A, it'd be a bummer, but B, yeah, you'd expect to see something like that, I think.
Thank you. Another question is trying to understand the relevance of epigenetic effects to the things you've discussed. Is it possible to comment on that? Are there intergenerational effects relevant to hypothermia, or any of the active stress treatments that you've talked about?
That is a really good question. I do not know. I don't know. I mean, nobody's ever looked at that. It's an interesting thing. We're sort of, that's a great question. I mean, now, so it's interesting. There are certainly now other processes, though. For instance, the integration of Neanderthal genes into European populations. We're like 4% Neanderthal. They're not evenly scattered. They've been wiped out in a whole bunch of areas where they were non-productive, but they've been held in a lot of areas having to do with fighting viral infections and things that you're more likely to come upon in colder climates. So there have been ways in which genetic mechanisms have adapted to thermoregulatory challenges. And body habits too, like Tibetans, they live in the coldest, highest place on earth. They're shorter, they're rounder. Neanderthals adopted the same thing across evolutionary time. The role of epigenetics, I've never, when I'm done with this, I'm going to go Google hyperthermia and epigenetics and see why I never saw it. It's a good question.
Maybe one or two more questions.
Sure.
Is there any studies indicating a relationship between hyperthermia and the CSTC loop of the brain? I don't know what that acronym means. If you don't know, we'll skip that question.
Yeah, that's a good one. Sorry, guys, too dumb for that one. Can't tell you.
I don't know what it means either. And maybe this is the final question. Do you know of any studies that have used weighted blankets in addition to heat that might also be helpful and produce positive outcomes?
Well, okay, so I'll tell you, I'll end in with a story. So I was in kind of a tough spot about 3-4 years ago, and I was broke. I had to get some money. So I thought, what can I do to get money? The only thing I could possibly do is write a popular book. So I decided I was going to try to go out and write a popular book on all the stuff we were talking about today in a much less well-formed way. I never wrote the book, but I did go out, I was going to go out and try all these adaptive stressors. And the first thing I did was I went to a place called, I think it's called the Shape House. Anyway, it was in Santa Monica, and it's a place where you go in and you sit on a chair and they put a weighted blanket on you and they cook you up. And so it has exactly that. And I was being a real snarky jerk because I was so unimpressed with the heat. They were going like, oh, now, you may have to, you try to hang in there for the last 5 minutes. And I had just put myself in our hypothermia machine, which you think you're going to die, So I was unimpressed, but I will tell you something. I sleep with a weighted blanket. I'm a little autistic, as you know, David, and there's something very calming. I've got a little stepdaughter that I always steal her weighted blanket every night and make her grab it back from me. So it's a good idea. And the Shape House was just being wimpy, frankly. It'd be a really, because it turns out that the tactile, the receptors, these trip receptors that are activated by heat are also activated by tactile stuff. So yeah, it's a good, there we go. Got another one. Get any hyperthermia people want to get into it, just email me. We could, do a blanket sweat lodge.
Well, on that note, I want to thank you, Chuck. This was great. And thank everyone for participating. Please come again next week. And I hope next time you speak, you can be in person.
Absolutely, man. I'd love to be back and hang. All right.
Bye-bye.
Well, nice seeing everybody out there. Say hello to the beautiful weather to me, tell it I miss it.
Will do. Good to see you.
Okay, bye, guys.
Bye-bye.